Okay, let's take a look at how we can write a program, solve a problem using this idea of decision structures. And at the same time, I'm going to also integrate some object-oriented programming in my approach. And by that, I mean that we're going to have a class that does all the work, and then separate from that, we'll have a driver class that instantiates a couple objects from that and tests them out. But all of the kind of the meat of the work will be done inside this. It's going to be called seasonal date. Um, and there are, as always, two things I like to remind students of as I get started on a video like this. The first is that I don't believe students learn very much by watching a teacher who's recorded a video of him writing some code. I think you learn by trying it yourself. So I strongly encourage you to hit pause, read through the problem, take a shot at solving it yourself, and then return back and press play once you're either stuck or done, and then you can see how I approach the problem. And the other thing I always like to point out is that I am not perfect when I program. I make lots of mistakes, sometimes big ones, often small ones, and I leave those in the recording. I don't really plan these out ahead of time, and whatever happens, happens. Sometimes they are not a great look for me, but I want to make it clear to students who are beginners that that is what programming is all about. For most of us, these programs don't explode from our heads fully formed with no errors. We make mistakes and we work our way through them, and that really is what programming is all about. So having said those two things, I would encourage you at this point to stop and read through the problem, hit pause, take a shot at it, and when you're done, come on back and watch the way I approach it. All right, so hopefully you've taken a shot at this problem. And as I start to look at it here, so this is a problem I no longer assign. That's one that similar to one that I used to use. I modified it a little bit. And I just want the students to have to write some if-else logic. And in order to make it to add one little layer of complication, I didn't want the seasons to start at the beginning or end of a month. I want these kind of midway points where if it's in March, we have to figure out, is it spring because it's before the 20th, or is it is it winter because it's before the 20th, or is it spring because it's March 20th or later? So I did that on purpose. So for that reason, I'm using these sort of astronomy definitions of the seasons, and they shift a little bit. And so there's that little note in there that I just pulled the times for 2023, and we're not going to worry about whether that's accurate or not for our code. That's beyond the scope of what I'm asking you to do here. I'm going to jump over to NetBeans Apache here, or Apache NetBeans. And I think this is about the first time I've used it on this computer. So there are probably going to be some little things that come up that I'll have to sort out. But I'm not going to, I'm going to leave those in the video because you're maybe still getting the hang of how NetBeans works or whatever IDE you're using. So this is going to be a decisions walkthrough, I'll call this. And I think the rest of that is fine. NetBeans by default will give me a class to start with. And often, I think probably the way most students do it is they just take the file that's given to them and they build from there. And there's certainly nothing wrong with that. But I'm going to intentionally delete that file if this ever finishes building my project. I'm going to delete that file and add my own so that you can see a little bit about the way NetBeans works. So it's made this decisions walkthrough class based on the name of my project, and that's not really what I need. I need a class that is called seasonal date, I believe was what the direction said. So I'm going to go ahead and delete this one. And I'm going to create a new one. Now, if I create a new one just in source packages, I can, and NetBeans will yell at me and say, that's not a good idea. Well, you really should put it inside of a package. We haven't really learned about packages yet, I'm assuming. But for now, a package, this was created when I created my project, and it's got this sort of funny semi-default name. that's fine. We'll learn more about packages later, but for now I'm going to add a Java class. I'm going to call this seasonal date and let that run. And here's what we get. I'm going to scoot my prompt over to the other screen on my computer so that I have it handy. And in fact, on that note, I type everything in the code while I work, but with one exception, I won't make you watch me type the header block at the top, which you do need to have. I'm going to delete the little extra stuff up there at the top, and I'm going to kind of repurpose this one right here. So I've got, all I did for my purposes, I just copied all the text, and that's not a bad way to start. I don't think that you should really turn in this as your documentation, but while you're working, now I have the problem handy. I don't have to keep looking at another screen or whatever. And very importantly, I have some test cases here, so you can see one of them is what we'd call like an edge case. So the 20th is when we switch, March 20th is when we switch from winter to spring. So that's a good date to test. Like, does it handle it appropriately right on that first day of spring? And as is always the case, as is always the way it works, 3 or 4 test cases is not enough to adequately test pretty much any program of any complexity at all. But it's a tough enough battle to get students to write a few of them, and I'm really just trying to build that habit of thinking about the way you test your code instead of just running it and seeing if it works. I want you to be thoughtful and say, well, how do I know if it works? So those are my test cases. And all right, so the idea here is I'm going to, it says that I need just some basic fields and stuff in this class first. So I'll start with that. These are going to be my fields. I like to document all of my work here. I also use the word instance variables kind of interchangeably with fields, so I'll list that. And we're going to have 3 of them. I need to keep track of the day, the month, and the year, all of those pieces. And so I'm going to have 3 fields. For now, all of our fields are private. It's something you're going to hear me say often in these videos, and I will continue to say it. There will come exceptions later on when we know a little bit more about object-oriented programming. But for now, fields are private. If you are making them public, it is either, I assume, because you've forgotten and you just put, I don't know why you would forget and put public there, or it's because you're trying to get around a limitation that is an intentional limitation. We make these private so that nobody else, no other classes can mess with them. And so if you need to mess with them from another class, the solution is not to make them public. It is to write methods that let you get to them. So, and I'm going to use integers. You could get clever, I suppose, and use something that took up a little less data since you don't need as much space as an integer will give you. But I use ints for my basic work. So we're going to have private int day, private int month, and private int year. And as I mentioned, this is all the decisions are going to be based on the year 2023, which is not perfectly accurate, but I'm not going to get into distinguishing different years in this code. So we will live with that flaw in this. So, okay. I'm just trying to scoot some things around in my other screen so I don't forget the problem that I'm working on. Okay. So it also says that I'm going to need get methods for each of those and a constructor. It doesn't say I need set methods. So generally or often, you don't need both constructors and set methods. If you have a constructor that takes all the data you need, you don't necessarily need set methods because you can use a constructor to get your values in there. But sometimes you want to be able to modify data later, and so set methods might be useful. I'm going to go with the constructor here. So public seasonal date, and this is not going to be a default constructor. Or parameterless constructor is actually more accurate, but this is going to be one that takes the day, the month, and the year and assigns them to our fields. So There are lots of different ways you can name these, and I do them differently in different videos sometimes. But for this one, since we're still beginners, I'm going to say new day, new month, new year. Month, new year. And the code inside here is really straightforward. I'm just going to say this dot day equals new day. Now, this dot is considered optional at this point because this just means it's referring to an instance variable, to a field. And so we're modifying the day value for this object that we are currently working with, or that we are currently inside. Java doesn't care if you put that or not, but I like to do that as a reminder that what we're talking about now are fields or instance variables, not just kind of local variables. New month, and this dot year equals new year. Easy enough. And then it says we are going to need some, I like to label my parts here. There's only one constructor, but in case we ever add one later. And then I like to have a section for getters and setters. Sometimes I give it a fancier name than that, but that's what kind of colloquially we call them. And so I'm going to need, getters are real straightforward. We're not even talking about decisions right now. This is just object-oriented programming. So I need a getter for each one. So it's public because this is how we access our private data. And then it's going to return whatever data type it's associated with. So day is an int. So it's going to be public int get day. It doesn't take any parameters. All it does is say return this dot day. And that's it. That's a getter. Sometimes getters are fancier than that, but this is the most basic version of a get method or a getter. We call them fancier programmers than we call these accessors. Right, that accessor is kind of the fancy word for a getter, and modifiers would be what setters are. Here. Okay. And I'm going to, so I'm going to actually hit the play button. There's nothing to play here, the run button, I should say. There's nothing to run because I haven't written a main method, but, and my poor little installation here is trying to unpack a bunch of stuff and failing at it apparently. Mostly because I want to show you kind of what happens. I deleted that default file. And so if I go to run this project, it is going to get confused, I think. Maybe it figured it out, but I think it's going to get confused. And I can't solve it right now anyway because I don't have a main method. So I'm going to skip over and take care of that. I'm going to make my my test method right now, my test class, excuse me. It failed because there's no main method to run. So I'm going to go ahead and skip to that part here. I don't believe that there's, I think it's really important, I guess I should say it this way, I think it's really important to test your code frequently. If you type for 30 minutes and then you go back and run it for the first time, you've got 30 minutes potentially worth of errors to debug. Whereas if you just type for a couple minutes and then run it, you can. Oh boy, I think this, because of this, this download is trying to do, my computer's really laggy. Seasonal data, it looks like it gave up, so maybe I'll be in better shape now. And this one is, I'm going to steal some of my stuff here. Demonstrates and tests. That's what I'm really more interested in. When I'm grading, I'm interested in your demonstration, but as a programmer, I'm interested in the testing. And so I'm going to need a main method. And this just comes, for now, like you'll learn what all these different pieces of this main method mean as the semester goes on, as the course goes on. But for now, it'll probably within a couple of weeks, it'll just become a line of code that you kind of memorize. And so this is to test and demonstrate the seasonal date method. So I'm going to need some seasonal date objects. Seasonal date, I'm creating an object using the seasonal date class. I'm going to call it SD1. I'm a big believer in descriptive identifiers, descriptive variable names and object names and stuff. But this is a pretty standard convention, so I also want you to know what the Java conventions are. So SD1 because seasonal date, and it's my first object. Date. And now if I just do that, I'm going to get an error. I might have a couple errors, but one of the errors I'm going to get is that my constructor, I said my constructor requires 3 numbers, and so I need to provide those. My first test case is 3/1/2023, so I'm going to put those numbers in there. Oh, and NetBeans has this, I find it annoying. It's this little miniature code that says the name of the parameters or the arguments that I'm passing in. It's meant to be helpful, and maybe it is to you. I don't find that helpful, so I think I can turn on the view menu, show inline hints. They're not part of the code. That's just NetBeans is showing you that for your own benefit. This is what the code really looks like. I'm not opposed to that kind of help, but I don't want to be confusing for people who are using different IDEs. You don't have to type that. You shouldn't type that. Okay, so that's going to make an object. And now to test it, I can just, in fact, I guess I'll get a little bit fancy here. I'll say string date stir equals, and I'm going to build a little string from that SD1 object. SD1 dot, I'm going to get we'll do get month, we'll do the US style, which is month first, plus, and I'm just going to kind of get a date the way that we're used to seeing a date. SD1 dot get day, another slash, and then the year. Get year, and now I'll print that to make sure that it's working. And now when I go to run this, I'm still, I think, going to have an error, but now I can fix that error. The error it's having is that it's looking for a main method in a file called decisionswalkthrough.java. I deleted that, if you remember. So I need to tell NetBeans, I need to tell the project where it's supposed to start. And so I'm right-clicking on the name of the project. It's got the little coffee mug icon next to it. And down under run, the main class is what we're interested in. So the main class is the one that starts the program running. And I only have one choice. What it's doing, I believe it's just looking through all the Java files in the project to see which ones have main methods. And if there's more than one, they'll all be listed here, and I can pick which one is the real one, the primary one. Okay, and I think now I can run this. All that work just to get this running, but I wanted to show off a little bit. And it's kind of buried in there and a bunch of other stuff, but there is my output. And I just made a dumb mistake. I put mine, I did day, I'm taking it in day, month, year. And I was thinking of it in month, day, year, right? That's the way most of us in America think of it. I probably should just change the order of these. So this is one of those mistakes that I hadn't thought about ahead of time. I think that's really the way that I want it, because it really should be 3/1. This is a little bit confusing. People who are from other countries, for example, have them in reverse order, what we consider reverse order. They have the day first and the month. Okay, so this is March 1st, 2023. Okay, so that was worthwhile because I was going to need this test class anyway, but I also, like I said, I want to test this before I get too far along in this process. Okay, so I've got my getters, I've got my constructor, and now I need a method called, according to the directions, I need a method called getSeason that's going to tell me whether this date is in spring, summer, fall, or winter. So this is going to return a string, public string, getSeason. And this is a get method, but it's a different kind of get method than you may have thought of before. Up until now, my get methods have had a kind of a one-to-one relationship with my fields. So each of my fields gets a get method. There's no field called season. I could make one, and I could make a string called private string season, and I could maintain that. But then it is one more piece of data to maintain. And what I would prefer to do is just make a method that sort of, to the person using the class, it's going to seem like there's a season variable. but I'm just going to on the fly, I'm going to look at what the date is and I'm going to return the variable. The advantage of this is that if I do eventually add a setter, sometimes our programs change over time and eventually say, oh, I need to be able to change the date. Or maybe like advance to the next day because it's it's overnight, and then you forget that well, if I'm going to do that, then I've got to recalculate what season we're in. So if you do it this way, it's always up to date. All right, so now it's time to think about the decision structure of this. Sorry, the microphone's probably picking up me drinking my water. The decision structure here. So there are a few different ways we could do this. There's probably, I'm picturing like an elegant solution maybe with switch statements, but I encourage beginners to focus on if and if else statements, because there's nothing you can do with a switch statement that you can't do with an if else statement. But the same isn't necessarily true in reverse. So if you're only going to learn one thing and you're a beginner just trying to keep your head above water, then you need to focus on learning how to use if and if else statements. So we're not going to use a switch statement here. I'm not going to. And what I'm going to do is I'm going to make a season variable, and I'm going to set it to unknown. And so I just got finished saying I don't want to make a season variable, but this is a local variable. It's not a field. Okay, it's going to get used when somebody calls the get season method. It's going to create this like as a temporary working variable, and then it's going to throw it away at the end. And so down here, I'm going to say return season. There are a few reasons I do this. One of them is because now my code will compile. If I don't return something, my code won't compile. But now I've also set it to like a default value of unknown. And now I can write all my if-else logic to check those 4 different seasons. And if none of those if statements gets activated, gets run, executed, then it's going to return unknown, and I will know that either there's something wrong with my if logic if I've given it a valid date, or it'll say unknown if I put the month as 24 or something like that, some invalid number or a negative number. So I feel like that's a useful thing. So I'm going to start with just the most basic case. So I'm going to start at the beginning. I'm going to start at month number 1. So month number 1 is winter. Month number 2 is winter. Month number 3 is partly winter, partly spring. So I'm going to pick off like the easy ones first. I'm going to say, well, the lesson here is that this kind of decision logic, it's more about thinking through how you want your code to work. I'm going to start off with the easy one. Say, well, if the month number is less than 3, meaning it's 1 or 2, then that's easy. It's winter. So I'm just going to say season equals winter. And in fact, I can even, winter. Can I make it a string? I can even test it at this point. And it's so, I'm just going to say, my test, I didn't actually output anything. So let's say, let's add this on and we'll say is in, and then we'll print out the, boy, I'm making all kinds of funny mistakes here. So that date is in st1.getSeason. So it should say is in winter, spring, fall, summer, or unknown. Now it says unknown because the month number is 3 and 3 is not less than 3, right? So it didn't catch that one case where like, I call these things kind of edge cases where there's more to it than just the month number. I have to look at the day number as well. So, I guess I could test it by, what if I change this to 2-1? Now it should come back and tell me it's winter correctly. Yep, it's in winter. So that part is working well. So now what happens if it is one of these months that are split? So I'm going to have a separate, I'm going to have an else if. And so the reason I'm going to use else if is an else if, the difference between a bunch of if statements and a bunch of if else statements is that an if else structure, each option, you can only run one chunk of code, right? So another way to think of that is as soon as it finds the correct answer, it stops checking the rest. So if the month number is 1, and it's winter, we don't need to check the rest of the seasons. We're done. So else kind of helps us short circuit it in that way. So, but I want to get into the case, well, what if the month is exactly 3? What if it is March? And so what do? Well, now I need another if statement, because if the day is less than 20th, March 20th is the first day of spring, according to this set of rules. So if it's less than 20th, if the day number is less than 20, then it's winter. Otherwise, it's spring. So that's easy enough. I'm going to say this dot day is going to be less than 20. Then season equals winter. Else, otherwise, and there's only two options here. It's either, because if the month is March, the only two options are it's either winter or spring. So I don't need else if statements here. Spring. Okay, so let's run again. First, this run will make sure nothing has broken, and it should come back winter. Good. So my first test case that I devised is actually working fine. I'm going to go ahead and work on the second test case. And to do that, I'm just going to make another object. I always tell my students never copy and paste because I think there's value in writing it out, but you're also watching a video. You don't need to watch me write it all out. And I'm also smart enough to know that my students are still copying a lot of this stuff. I just wish you wouldn't, because I think there's value in sort of the finger repetition of typing them. Okay, and same thing here. I'm going to copy these two lines. Now, so I'm going to get an error. I'm going to first of all change these SD1s to SD2s for the second seasonal date. And I've got this error where I can't make another variable with the same name. Whenever I put string or int or the name of a data type and then a variable name, I'm telling Java I want to make a new one. I can make a new one, but it can't have the same name as an existing one. So I've got two options. Either I can change the name datester, or I can say I don't want to make a new one. I just want to use the old one. I'll just use the old one. Right? I've printed it out for the first date, and now I'm going to reuse it, repurpose it, and see if that works. Yep, so 3.1 is in the winter, 3.20 is in the spring, and I think I'm off and running now, because it's going to be just kind of more of the same. If this dot month, I've made a mistake that is not uncommon. I've started my code in the wrong spot. I am still inside this if-else statement. I need to be outside of it, and that's why indenting is important. So I need to be here. Else if this dot month is, okay, and now this I guess kind of gets interesting. So now we're in spring. So we've handled March. Now I want month number 4, month number 5, and month number 6. In month number 6, we switch to summer. But if it's 4 or 5, it's still spring. So I can write this because of the order I'm looking at these months. I can just say, I don't have to do what we would call a range check. I could say if it's, greater than 3 and less than 6, then that would tell me it's either 4 or 5. But if it's less than 4, that's already been taken care of, right? Because that's 3, 2, 1. So all I need to check is if it's less than 6, and that's because I'm using these else ifs. Once it's found an answer, it's not going to run. It's not going to keep checking. So else if we're less than 6, then I'm going to say season is equal to spring. And now we've got that sticky case again of how about if it's exactly month 6? How about if it is June? Month equals 6. So same kind of thing. We're going to say in June, it's the 21st is the first day of summer. So if the day is less than 21, then we're still spring. Otherwise, and I don't need the curly braces for this since I'm only putting one line of code, but it's good to have them just as a habit. Otherwise, we're now in summer. Okay, and I think I had a summer test case up here. So 6/28 2023, John Elway's birthday, in case you are wondering. Now we're going to do seasonal date 3, my third object. That's going to be 6/28. I don't know what year John was born, but we'll just leave it as 23. And I'm going to, same thing, I'm going to repurpose some of my old code here. 3, 3, 3, 3, and we'll run it. 6/28 is in summer. So far, so good. And it's you. Hopefully by now you've got the kind of a sense of where this is going. It's just running out the string, so to speak. It's just doing the rest of the checks. And so now we've got until the transition from summer to fall is in September. So if this dot month is less than September, then we are very definitely in summer. And if it is exactly September, then it might be summer, it might be fall. So else if this dot month. I might also, as I'm trying to type and talk at the same time, might be worth mentioning, I never make claims that the way I write my code when I'm writing for the sake of students, I never claim that I'm writing the most efficient code I could possibly write, or the way that I would write it if I'm just coding for myself. I'm writing code that students are looking at. And so some of you, especially if you're a little more advanced, or if you just get this stuff quicker, you may be going, why would you do that? There's a better way to do this. It'd save you so much typing. There are better ways to do this. But this is a way to do this that students who are on this chapter of the textbook, starting from the beginning, know how to do. So that's why I'm doing it. This day, I think I said it's the 23rd. 23rd is the first day of fall. So if the day is less than the 23rd, then the season is still the summer. Indenting is getting a little crazy here. Otherwise, it is fall or autumn, if you prefer. And I sort of feel I'm starting to get a little bit cocky now. I'm like, well, maybe I don't need to test it right away. But it's good to run your code often and make sure everything is still working that I've written. So October 1st is my next test. And I think on that test case, I even changed the date. Not that it matters. It should matter in terms of astronomy, but for our code, it doesn't matter because we don't look at the year. But your test cases are intended to be what we would call robust, meaning it checks lots of different possibilities. I actually think there's a lot of value in having test cases of like, what happens if the user puts in a negative number or a 0 or something like that? Those things happen. Users do crazy stuff. But it gets pretty big at some point. So I've got an error there, but on that train of thought, that software testing, or something like might be called quality assurance, is a big job, and lots of programmers get their start in the industry by doing quality assurance testing, because it's really important, and it takes a lot of time, and it takes a lot of thought, and it's one way you can show employers and supervisors that you understand programming, is by being able to think through, okay, here's this piece of code. How do I test it to make sure that it works right? I've got an error here. Let me see what my error is, because 10.1 shouldn't be unknown. That should be in the fall. I just haven't gone far enough to test it, I think. So I stopped one if statement too soon. If this month is really less than 13, which sounds a little bit funny when you're talking about months, but and I guess for that reason, if it makes you feel better to say something like that, like it's less than or equal to 12, because the logic of that makes more sense to you. There's no month greater than 12. And once again, forgetting my quotation marks. Let's try that, see if that catches my little mistake there. Yep. And I'm going to do, even though I didn't write a test case for it, I'm going to test one more thing. What if I do put some crazy number in here, like 100? What happens? It's unknown because and that makes sense because that's not a valid date. You could write, you could change the word unknown. You could make it say invalid or something like that. But the idea is that it has handled that appropriately. It shouldn't say winter if if the month is 100 or something like that, because that's not correct. Okay, I am just taking a look at my prompt for the program and making sure that I haven't forgotten anything, and I don't think I did. Um, I will I'll take a moment just to point out that often in these prompts that I give you, I will specify whether or not you need user input. And so this one says specifically that you do not need user input. But if it does, then I could address that by having a prompt that says type in the month, type in the day, type in the year, and then I would do that like up here, and then I would call it, and instead of putting 3/1/2023, I would put the names of the three variables I used to capture their input. So I won't take the time to do that at the moment, but that's a pretty straightforward change. I think that's it. As always, I encourage you to reach out if you have any questions.